Hello, and welcome to Answer Everywhere. Today, we're taking a look at Gnome Shell, or Gnome Shell. Apparently, both are acceptable pronunciations. I'm going to keep saying gnome, because it's hard to remember to say gnome, and it's also kind of a weird thing to say. So, Gnome Shell should be pretty big. It's the core user interface functions for the GNOME desktop, like switching to Windows and launching applications. So this is probably both technical and relatively large. I've been keeping these streams to an hour because I'm still in the process of flushing the old backlog and making some space so that newer requests can get done earlier, and also so that I can also set some of the schedule more flexibly for my own interests and purposes. So, with only an hour, we're not going to get to see everything. It's like having only an hour at Disney World. And so we have to make some decision about what we want to see and what we're willing to let go. I do have a downloaded version of this code just in the background here. Let me make sure that I have tags for it. And let's open up Emacs, just so we have it available. Good. Otherwise, we can try browsing in GitLab. I don't think I can search effectively. Oh, can I? I can type commands. What if I look for widget? There must be a widget. Yeah, okay. And is the search clicky? Not really entirely. Maybe some of it is. All right, so let's see what we got. We'll take a quick look at this README. I didn't know it was just the user interface functions, so this sounds basically like an API. Maybe that's what it means by shell. And it emphasizes particular things like switching to Windows and launching applications. So those are kind of servicey. And then maybe the idea is that the rest of GNOME kind of takes those services as given and is building applications around them. We take advantage, or rather, Gnome Shell takes advantage of the capabilities of modern graphics hardware. So we're probably going to see hardware acceleration, and introduces innovative user interface concepts to provide a visually attractive and easy to use experience. Just for fun, let's also open up the bug tracking system. So we have some features. They have to happen in accordance with the GNOME design team. That's good for major changes, blah, blah, blah. Oh, this is feature requests. I thought that was features for a second. So we're not going to do that. We have coding styles and conventions for JavaScript, for C code, the JGS developer guide, maybe GNOME JavaScript, building and running, etc. Okay, so let's look into the code. So we have JS. It sounds like JS is a big thing for GNOME. And we also have lint, which we're going to ignore. Man, Maison, and Poe, I know we can ignore. Source is probably important. Sub-projects might be. Tests. I have just, for whatever reason, I'm feeling tests today, so we might look at tests. Data, let's see if we can rule out data being too interesting. Doesn't look so interesting. We have some things like perf background XML. I don't know if that's some user interface for doing perf stuff. And some things that seem like they are probably utilities, like CLDR to JSON, dbus interfaces, icons, maybe dbus interfaces. That's the build file. How about dbus.xml? We haven't looked at much XML, but it's basically it's similar to HTML, except whereas HTML describes like a document markup with things like headers and titles, XML can describe arbitrary things, of course. So we have some node. This is presumably a node in a tree, so we're defining a tree, and the elements or leaves of the tree are going to be in possibly different files. What does one of the things that the tree apparently can hold is an interface. Interfaces have names and methods. Methods have names and arguments. And in fact, the arguments are nested inside the method, as opposed to, you could imagine the arguments being listed outside the method, and then you could like point to those outside arguments, so those arguments are passed to a bunch of stuff. But at least here they're nested inside. Similarly, names are nested inside the interface. This interface has 2 methods, namely the ability to list names, I guess from dbus, and the get connection Unix process ID. And the arguments, there's 2 arguments. One is S and one is U. S is an input argument. U is an output argument. I don't know how many output arguments you could have. If this were Go, you could maybe have 2 or more output arguments. But maybe for XML, there might only be 1. I don't really know. Although here, we see that there's 3, so I do know. And we have this signal, name owner changed. And I suppose this is probably a signal you can subscribe to in some way. And the output arguments are the name, the old owner, and the new owner. So that's just an example of a dbus XML thingamajiggy. Should we look at user, login one user? Yeah, why not? So a free desktop .login one user has 2 properties, display and sessions. I don't know what type parentheses SO means, but it has some sort of read access. Read access to what? I have no idea. But that's just a little, a little flavor. Here's the issue tracker. I'm going to put that in the background. All right, so here's the JavaScript folder and here's source. Okay, let's maybe take a quick look at subprojects. You have the extension app, extensions tool, and shoe. I'm guessing these are probably mainly extension points. Gnome Extensions is a small app for managing Gnome Shell extensions. Okay, maybe this is an app for managing extensions. We can ignore that safely. Which leaves us tests, source, and JS. Let's look at source first. So in source, we get a few, non-trivial amount, I guess, of C files and their headers. And we also have a small number of folders like hot plug sniffer, calendar server, which is a little bit odd to me that that's one of the, that seems to be it seems to be a pretty central place for a calendar server in GNOME. But maybe it's fundamental for some reason. ST, I don't know what that would be, and tray. Tray is presumably like system tray where things go and live. Although, I guess it's true that any desktop environment you have like a time and calendar app. So I'm guessing that's part of what this is. I was thinking calendar server in the sense that like, an iCal sort of server, but that's probably not what it is. All right. And then so we have a bunch of C files and headers. Let's pick out a couple that look especially Shelly, like shell app and shell C. Shell app system? I'm not sure. Shell global? Probably not. Invert lightness effect is probably not fundamental. We have key rings. Key rings are pretty important because they do a lot of things that if you don't have them working properly, things break. Things like password management. A shell perf helper, perf log. We can probably ignore polkit. This is some sort of polkit support. Screenshot support. I guess let's look at screenshot. I don't know what a square bin is. If it's different from a like recycling bin. I guess we'll look at a square bin. Shell stack might be important. Tray icon. I guess let's look at in tray manager. Window preview. I guess I don't care about. Window tracker, maybe. And shell WM, I'm going to assume, is window manager. And we'll just open up the workspace background header. Hot plugs differ, I'll ignore. Tray is possibly fundamental, but we have some system tray stuff open already, so maybe we can ignore that. And then what's this other one? ST bin, ST focus. st scroll view. These seem important. These are pretty widgety. We have like a viewport. We have some theme stuff, node transition, theme context, shadow. This is more graphics stuff. Like we're getting closer to maybe the GPU stuff. I still don't know what ST is, but perhaps we'll see. I guess we'll open a few of these just in case, and if we don't get to them, then we don't get to them. Clipboard might be fun. Button might be fun just as a simple entry point. Okay, so that's source. I'm going to look in JS. I'm going to probably mostly omit JS stuff. But we have UI. And I guess we'll pull JS into its own window. So UI is, I'm going to guess that, I don't really know what's going on, but I imagine that one thing you might do if you were GNOME or other UI toolkits is that you would just use HTML for display, CSS for style sheets, and JavaScript for organizing the display. And that makes essentially everything a kind of web view. And I imagine that might be what's going on here. So with that in mind, D&D is probably drag and drop and not Dungeons and Dragons. Main might tell us a little bit of something about what we're doing. Overview.js. That might be like an expose feature or expose feature. I think it's like this thing. Maybe we'll look at overview. Remote search, screenshot, scripting, shell entry, slider, window menu, workspace, ripples. I'll open ripples. And that will at least give us a little bit of a flavor. And then in tests, let's just see a little bit of a flavor of what their test is, maybe try to get a sense of what their test discipline is like. We have dbus mock templates. I'm guessing these are mocks of dbus templates or tools for mocking dbus templates. We have only one thing in the dbus mock templates, which is a Python file about account services with this add user function. So this is, I guess, like a mock implementation perhaps of a dbus service. I have exited the test directory. All right, what else do we have? We have data, which just consists of a single PNG. We have common, which is a single JavaScript file. We have unit, which has 1, 2, 3, 4, 5, 6, 7, 8, 9 JavaScript files that were all updated months ago. So I suspect that this might be under-tested, unless I'm missing tests. Oops. Automated tests are important to ensure software continues to behave as it's intended. Test everything. So it says in the Gnome Shell developer stuff that we should test everything. To actually test enough things, we need to run all of Gnome Shell with its features, as if it were a real session. So I'm not positive that they really are testing everything, but it's possible I'm also missing stuff. Let's look for just test. So we have some, I guess, maybe test stuff in colder to JSON, which is not in the test directory. It's in the data directory. And we have this run tests shell scripty thing. We didn't look in test shell. Maybe that's where I should have looked. Test shell. Yeah, just a few JavaScript files. So, I mean, it's possible that these files are large enough that they do test everything, but I would guess there's kind of a gap here. Okay, that's fine. That's not the end of the world. Gnome Shell seems to be doing just fine without an infinite number of tests. And obviously there are costs to testing, both in developing them, keeping them up to date, and also the cost, of course, of running them all the time. Okay, so with that out of the way, where do we want to start? Let's start with the AIs. I've messed up my workspaces. This can't be. Let's send these to workspace 1. That's where I like them to be. And I'm pretty sure I can just, I'll send issues to workspace 4. That's kind of like banishment. Okay, and then let's ask Gemini, assuming I'm still logged into Gemini. Also, how is you know what? I might decide to increase the font here. I decreased the font for development. But when I was looking back at some of the videos, I feel like for the code reading videos, it was maybe too small. Can I just like scale the font? Let's try this. I don't know if that applies to, I don't know if Emacs is smart enough to have its font scale. Let me just restart Emacs. That seems better. I don't know why it's taking so long. All right, well, whatever. Okay, so I guess let's start in the C code. That's where I feel is probably the root of things. Here's shell app.h, the shell header. We have only about 97 lines. This is probably mainly like an entry point to a bunch of other stuff. Although not everything is extern, we do have some enums, shell app state. So shell app, it's pretty verbose, but actually not so bad. Actually, well, it's easier to read in enum if it says shell app state stopped and you don't see the explicit type. So that's kind of nice. And I don't know if you really pay a price for having long enum names. And then we have this shell app launch GPU, which I guess is going to tell you whether you have access to the GPU for things like optimization. All right, so we have a couple of enums, such as whether we have access to the GPU. That makes sense. And then we have some functions like shell app activate. And you pass in a shell app. Whatever a shell app is, we don't know yet, but presumably some model of an app that either lives in the shell or uses the shell being Gnome Shell as opposed to like a terminal shell. You can activate full. And when you activate full, you pass in not only the shell app or a pointer to the shell app, but also an int specifying the workspace and a timestamp. A workspace, I guess, probably schedules it on a particular workspace. Like these are my workspaces right now. And I don't know what timestamp is for, but we're using Nguyen, so I think we were using glib somewhere. We're also including clutter. I don't know what clutter is. Clutter library. It's a discontinued G-object-based graphics library for creating hardware-accelerated user interfaces. If it's discontinued, then why are we using it? What if we look up Gnome Shell clutter? Retiring clutter. Clutter has been in deep maintenance mode since 2016. Starting from GNOME 42, Clutter and its related libraries, Coggle, Clutter GTK, and Clutter GStreamer have been removed from the GNOME SDK runtime. So then what am I reading? Am I reading old code? I'm on main. And Let's see if we have 3 months ago, 2 months ago, 9 months ago, 2 weeks ago. It seems like this is not outdated. And what was this announcement? Starting from when? Gnome 42. Here's Gnome 45. Let's just see if they have clutter. Where was I? Somewhere. I think like a shell app.h. Yeah, well, we're still including clutter. I don't really know what that means, but apparently they're no longer going to include it. So, so somehow they claim that they're not including it anymore. Okay, anyway, moving along. We can get PIDs. You can get whether the app is busy, whether the app is busy and it returns a Boolean and stuff like that. So this is really like a pretty high level entry point for what the API is for dealing with apps in the shell apps. Here's, should we look at main.c? I don't think we have a main header. We'll take a quick gander at main.c. Is it big or small? There's two approaches to main.c. One is big and the other is small. This is kind of like a little bit on the big side. So in main.c, we have things like acquiring the dbus thingy, whatever you call a dbus thingy. It's like a basically an RPC mechanism, right? Is that the right way to think about it? It's a messaging system of some sort. Software communication protocol, message-oriented middleware that allows communicating between multiple processes running concurrently on the same machine. Its predecessors were Corba and DCOP. Oh, IPC. Yeah, I keep forgetting about IPC. Dbus is closer to an RPC mechanism than classic IPC mechanism, with its own type definition system and its own marshalling. Messages have a well-defined structure. Even the types of the data carried in their payload are defined, allowing the bus to validate them and to reject any ill-formed messages. I thought IPC could also have the same thing. What? Do I not get a link to the IPC article? So the IPC article is telling me that files are a means of inter-process communication. I guess that's true. Sockets, Unix domain sockets, named pipe, shared memory, message passing. I've always thought of IPC as message passing, but I guess these are all, valid. And now I want to know if Corba doesn't have types. So Corba uses an IDL, an interface definition language, to specify the interfaces that objects present to the outer world. It then specifies a mapping from IDL to a specific implementation language like C++ or Java. From IDL. That seems like the mapping goes in the wrong way. Standard mappings exist, blah, 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 blah. I think that I'm going to assume that means you basically generate code in those languages. Okay, so you can acquire the dbus name, shell dbus acquire name. I don't know what acquiring a name means. Maybe that means you register yourself as the server. Maybe it's really like grabbing a client of some sort to dbus. We have this gdbus proxy, which seems to be maybe a glibc type. And we have some things like name flags and name result and name and fatal. And static void, I'm going to guess name result is an out parameter. Name could go either way, although conventionally if it's after an out parameter, it's also an out parameter. Fatal is not a pointer, so I don't think it can be an out parameter. But let's look at, let's look for request name result. Let's highlight all, request name result. So we're going to call it get. Oh, okay. I think that it's an input. I think the way the thing about this maybe is this is an input parameter to shell dbus acquire name in one sense, but it's being used as an out parameter to gvariant get, I think. So it makes it kind of an out parameter and kind of an in parameter, if that's sensible. I'm not sure if conventionally that's just considered an out parameter. At any rate, we have some dbus stuff. We can initialize dbus. What else do we need to do? Maybe add rpath, introspection paths. So rpath, I think, is just real path, right? So we have elf w, dyn. I guess this is like a dynamic elf, something or other, like a binary, rpath, run path, stir tab. Stir tab, like string tab. I don't know what stir tab is, but we seem to be like figuring out paths here and doing something with them. I guess the GNOME shell needs to call various binaries. So maybe that's what that's about. We have some introspection stuff. I don't know what introspection is doing. We have some shell font stuff. We can initialize the profiler, which should be just about performance. malloc statistics callbacks also is probably performance related. Maybe we can init debug sessions and log writers. Those are probably for debugging performance and stuff for developers mainly. What is this stack stuff? Dump GJS stack on signal handler. I'm guessing that whatever GJS, maybe GNOME JavaScript stack on signal handler. Maybe when you receive a signal, it'll dump this stack so you can debug it. Ignore all signals starting this point. Okay, so that's just a flavor of main. Let's see if we can find the main. I saw change home directory. So main, we're going to do a bunch of setup. We're going to call it dump this stuff. So we're going to dump the GJS stack on sig abort, sig FPE, sig IoT, and sig trap. Sig abort and sig trap, I know what they are, but sig FPE, something, floating point error. A fatal arithmetic error. Although the name derives from floating point exception, the signal actually covers all arithmetic. Okay, so I don't know if that includes division by 0. And then what is the sig IoT? Signal input output trap. Okay, so these are all various bad traps, and if we get them, we're going to dump the JavaScript, what I think is probably the JavaScript stuff. And then we might do some debugging, some stuff about script paths. I'm going to just kind of plow along and see if I can find anything. So if we get down here, we're shutting down. So somewhere above here is some infinite loop that's going to do the main handling of stuff. And where is it? If we're here, we exit failure. I'm going to guess that this is the loop. You have the profiler in it, initializing fonts, initializing introspection and perf and dbus, and A11Y is accessibility, like support for people who have low vision or no vision or struggle with other things. Like, I don't know what other accessibility support it has, maybe dyslexia, maybe people who struggle to use ordinary keyboards or pointers. And then we have the status. So this must somehow be the infinite loop. So we're going to say, if not, GJS context eval module file on this thing, we're going to error. So that's not infinite loopy. And if we get down here, we're shutting down. So where did we do work? You got this get context and a status. So we're going to call it GJS context eval module file on GJS context, passing in, I guess, this init.js. So it probably somehow invoking this JavaScript init function. And maybe we can figure out where init.js is. Let's do that now. So we'll open that here, I suppose. And passing in the status and error so they can presumably be filled in by this stuff. So if this doesn't happen, then we error out. So if it does happen, we don't go into this clause, this section. And so I think this is the infinite loop. It's just not clear. I think this must be, this init file must cause looping to happen. All right. So that's how I'm going to think of it. Let's maybe take this moment then to look at init.js. So that's kind of an extension of main. And we don't have much. We've got set main loop hook. That sounds very promising as the this is the main loop. It's the thing that starts the main loop. And this is some promise native. I don't know how that's different from other promises, but this is just some promise. And what is it going to do? We're going to call glib idle add. And I guess glib is some glib JavaScript thing. Gnome JavaScript. So this might be developed by the Gnome people. It's the first thing that comes up if you look for glib and JavaScript. Okay, so glib idle add, we're going to set the property to default. We're going to import main.js, and then after this is imported, we're going to call main start, and this must be the infinite loop here. And then we're going to catch any errors. So there's a glib error. We might terminate with error. And then we're going to return glib.sourceRemove. I'm not sure what that does, but it does something. And then, assuming this all succeeds, we're going to call global.context.run main loop. So this is for sure the main loop. And I don't know what main start is doing, because it seems like this must be the thing that runs forever. So can I ask folks, how's the quality? Let me see if I can find out stuff about, let me look at stream health. Stream is healthy. Okay. All right. So this is the infinite loop, and then we have two possible ways to go. One is that we are going to look at more C files, and the other is that we're going to look at more JavaScript files. I guess let's pass through the C files, pass through the JavaScript files. As I mentioned at the head, this is going to be a pretty whirlwind tour. So let's see how that goes. Okay, so here's the shell keyring prompt.h. We've got more clutter stuff, which I thought we were getting rid of. And we have like a function shell keyring prompt new, I guess, causing a new prompt. And we have password actors, where maybe actor we're thinking of as a background service that handles password stuff. And we might have I think we're getting and setting the same password actor rather than having a different actor that gets and an actor that sets. Although both would be possible implementations. And then we have this keyring complete thing that returns a bool. I guess it tells us whether the prompt has been complete, and then we can cancel. It seems like we can cancel the prompt. Shell screenshot. This is probably just like the API, right? So this is like take screenshot, and what do? You pass in a screenshot. What do we get? A struct? Declare final type, shell screenshot, GObject. Define shell type screenshot, shell screenshot get type. I don't know what any of that means. Is there a struct somewhere that tells me like what things are in a screenshot? Maybe. I'm not sure. At any rate, this is like the API. What can you do? And all of this should be kind of essentially visible from like the GNOME written version of the API. And For folks who are on the stream, how's the stream quality right now? Is the video laggy or pixelated? Okay, so let's see if we can find something like a screenshot type. Maybe it's in the C file. We have a struct shell underscore shell screenshot, which has a GObject parent instance, and a screenshot private.priv, star priv. I think this is probably the thing that that the macros we just saw was sort of registering. Still good. Okay, thanks, Segfault. All right, so here's shell screenshot private. We've got some shell global. I don't know exactly what that is. Maybe some just reference to the top level pointer to the shell. We have an output stream, presumably where we're going to write the file to. A screen, some flags, a mode. I think the modes might be things like screenshot the whole screen, screenshot a particular window or a subregion. We have a date and time, a Cairo surface, which is called image, a screenshot area, whether to include the frame. I'm guessing the frame is like this thing, the window frame around the stuff. Whether scale, presumably how much to up or down scale the image. Clutter content, which is cursor content. I don't know really what that is. The cursor point, which is a graphene point, and the cursor scale. I don't know what that stuff is about. Let's look up GNOME screenshot cursor. See if there's like cursor options, like with a current cursor in GNOME. It does not show the mouse. So I guess maybe screenshots hide the mouse, and then you can configure whether to show it or something. And maybe since it's like a separate image, you get to scale it. I don't know what graphene point is. Presumably some point object in some graphene library. Graphene reference manual. Okay, but what is graphene? This is like a manifesto. When creating graphic libraries, you most likely end up dealing with points and rectangles. If you're particularly unlucky, you might end up dealing with affine matrices and 2D transformations. If you're writing a graphic library with 3D transformations, though, you're going to hit the jackpot. 4x4 matrices, projections, transformations, vectors, and quaternions. So we've seen lots of those. We've done lots of videos that have looked at such things, including, off the top of my head, Blender, Ogre 3D, probably the one whose name I'm forgetting now, Godot engine. We've looked at a few of these engines that have a bunch of these matrices and stuff. Most of this stuff exists in various forms. Okay, so this is some library for graphics. I guess they do 3D graphics, but we seem to be using them here for mainly 2D graphics. And where are we here? Are we still in screenshot? Or did I look at the wrong window? And then the other one I wanted to see was Cairo. I don't really understand what Cairo is, although I've seen it lots. So Cairo library. Use the public library, I guess, in Cairo, New York. Cairo graphics. That's the one I want. A 2D graphics library with support for multiple output devices. So why does GNOME use GNOME, Cairo, graphene? Let's see if we can find anything else. Maybe Cairo doesn't really support GPU rendering very well. Okay. All right, so let's move along. I don't know what a square bin is. I guess it doesn't really matter. Shell stack. The headers are now pretty small. We're just mainly defining these G declare type final type stuff. This is like G. I don't know if this is glib or GTK. Yeah, this is GTK stuff. We have looked at the GTK software source code, but we're not going to look at it now. We have this tray icon thing. I think this is probably mostly all of this stuff is going to be kind of defining some structs. I guess we're defining signals as well. and implementing some of the wiring. And then I think a lot of the heavy lifting in practice will be probably written in JavaScript. So let's take a look at the JavaScript. We'll look at a few of those and then probably take a little bit of a break, maybe about 1 or 2 minutes, and then move on to XLA. Did I close all of my windows? I don't think I meant to do that. Can I do this? There we go. All right, we looked at init.js. Let's look at drag and drop.js. Again, we've got clutter, which you shouldn't have. Meta, I'm going to guess is not Facebook related, but is like meta stuff. The Gnome meta package. I'm not sure. Well, maybe we can see how it's used. And then how does drag and drop work? First of all, it's pretty big. Second of all, it probably invokes at some point the GPU. We have to figure out either we're using a library that already has some drag and drop support and we're just kind of wiring things together, or we have to do things like when we if we're dragging a window, we have to figure out the overlap with some other window, and we have to like listen for when the mouse pointer lets go, and when it lets go, we have to figure out which like 2 windows are overlapping, and then if they are overlapping, we have to somehow dispatch the drag and drop call that might say, you know, if the source window is a folder and the target window is a folder, and the default action is copy, then we'll execute the copy command recursively over all of the files in the folder, or something along those lines. So let's see if that mental model is more or less what we have. So we have a drag motion result, which has no drop, copy drop, move drop, and continue. So copy and move, I guess, are the 2 things that they really have, and then whatever continue is. I don't know under what circumstances you drag and drop something and then expect it to continue. Drag state is init. That's probably like clicking. Dragging, that's this, moving a window around, and canceled. But dropped is not a state. We have the drag cursor map. The meta.cursor. So cursor is one thing in meta, but we have there could be an unsupported target, and then copy and move. I don't know why copy and move here in the cursor are different from here in the drag motion result, but they presumably have some reason. And then the drag and drop result itself can be a failure, a success, or continue, whatever continue it is. And we have some drag monitors. We're in JavaScript now, so we don't have types everywhere. I don't know what types the drag monitors are. We also have an underscore get event handler actor, and we have some notion of an event handler actor, which is a clutter actor, which can still seems like we're still depending on clutter. And I guess so. Clutter has some support for actors, the actor model, which I'm going to basically think of as like a microservice inside of your app, just some process or thread that listens for messages, sends messages to other things, and can occasionally do things. And then we're going to add the event handler action as a child to the main UI group, and that essentially gives, I guess, the main UI group access to the ability to handle events. And we're going to connect on the event handler. We're going to call connect, passing in the literal string event, I guess, a function that takes an action in an event. This is like a lambda, an anonymous function. I'm not sure what they call them in JavaScript, but I'll call it an anonymous function. But it's going to take the actor and event and call current draggable underscore on event, passing in the actor and event. So whatever the current draggable is, I guess this is a a variable that gets populated based on what you're dragging. And what is this doing? So I guess the thing that you're dragging has an event thing on its own. And this is maybe just registering it so that when the drag and drop happens, this is perhaps the thing that gets called or something along those lines. And then we're returning the event handler actor. We can get the real actor scale. I don't know what that's about. Maybe if we've scaled the display, then we have to possibly unscale it to figure out things like overlap. And then we have this drag monitor stop drag motion. We can add a drag monitor, which just pushes it onto the drag monitor. That's not so exciting. We can remove one. And we have a class draggable. So I guess different things can implement draggable. Is that what's up here? No, that's different. Okay. So to implement draggable, which extends event emitter. So a draggable is in particular something that's going to emit an event. We have this constructor, which takes an actor and params. And we're going to parse the parameters. Such as whether we're in a manual mode, whether there's a timeout, whether to restore on success, and a max size and opacity for the drag actor. We set the drag state to init initially. And if we are not in manual mode, then we're going to listen for button press events. And on button press, we'll bind this. This, I think, being the draggable. And we're going to listen for touch events. And also bind this. So I'm guessing that button press is for mice and touch events are for like laptop touchpads or something. And if we destroy, then we need to do some deconstructor stuff. And then we have like an event ID, which is null, restore and success, etc. Just setting those things up. And we have this clutter click action, which will add a draggable actor. And I'm going to kind of just blow past the rest of this. I'll look at on button press. So if you call on button press on the actor in the event, then if the button is not one is maybe the mouse click button or something, then we're going to return event propagate, which presumably causes other handlers to look at it, or other actors. Otherwise, we're going to grab the actor from the events device, and using that, we're going to look at the X and Y coordinates. I don't know what stage means. Like these are some sort of staging coordinates. And then these are we'll set those to the start X and Y coordinates of the drag. And we'll set the start time to whatever the time of the event is. And we'll set that the threshold is not ignored. And then we're going to call event propagate. So this event has like flown past us. We've grabbed some metadata from it, and then we're sending it back on its way. And similarly for on touch event. And then event is released. This should be when the button is released. So either the button's released, or no, really just that's just it. Then we set some button masks. We only obey the last button released from the device. Other buttons may get pressed or released during the D&D operation. Okay. So I guess this is I don't know what this is. So if the get state is end button mask is 0, or rather, sorry, we're just returning this. And if it's touch end, for touch, we only obey the pointer emulating sequence. And then we return this. So event is release is only really just calculating whether it is release. So on event, if it is the release, then this should be when we call stuff. We intercept the button release event to know that a button was released in case we didn't start the drag, to drop the draggable in case the drag was in process. And to complete the drag, and ensure that whatever happens to be under the pointer does not get triggered if the drag was canceled with escape. Okay. So if drag was never started, we propagate the event. If it's canceled, we call event stop. And we may have dropped the thing. So I guess if we're down here, we just assume, where do we actually do stuff? Maybe drag actor dropped. Let's see this. So if it's drag actor dropped, I think dropped in this case means we're dragging and dropping so that we successfully dropped. In that case, we get the coordinates for drop X and drop Y. We get the stage, get actor at position, passing in whatever the pick mode is. I guess pick everything at that position in X and Y. So we get all, presumably this is like all the windows or actors that are there. And we call observers only once per motion with the innermost target actor. So we create a drop event. And for all of the drag monitors, we get their drag drop function. And if it has a drag drop function, we call it. And that's, I think, how we do things like copying or whatever. Although I'm not sure we've seen them use like copy. Maybe it's up to the monitor to use like copy, drop, and stuff. See if we can find references to copy, drop. So, yeah. It seems like thumbnail has some reference to copy drop. So there's kind of wiring up some behavior for what happens when you drag and drop. Here's main.js. This is probably too big for us to really look at. We see things like we're going to initialize the UI, which must be async because we're awaiting it. We're looking at things like the controls manager, which probably has some config because it has some default. This is the start function. And this is going to be like the main function, I guess, that sets up the user interface. And I think I'm mainly going to just kind of close out the rest of these files. For overview, I don't know what overview is, but let's see if we can figure it out from the context. I think that maybe this is where you see a bunch of like a tile display of different apps or icons. So this shell info class, where we can do things like set a message. It has titles, options, get system resource, some stuff about notifications. We have an overview actor. So everything's like an actor. And we have some constraints. Layout manager, monitor constraint 2, true. Primary true. Maybe primary is primary screen. So I guess if you do overview and you have multiple screens, then the overview should only show on the primary screen. That is, I didn't see monitor constraint here, or at least I didn't register it, but that lends heavy credence to that theory. And what else do we have? We have like an accessible name, which I guess is maybe like a screen reader might read it, whether it's vertical. And we're going to add child some controls. The controls are something from controls manager. Presumably controls manager is going to listen for things like key presses or something. And we have things like run startup animation, animate from overview. I don't know what sort of animations we have. And then overview show in state is hidden, hiding, showing, shown. And then we have transitions. So if we're in the hidden state, we are allowing the transition showing. This is kind of defining a, I almost said Markov chain, but this is just defining the state, like the state machine, the state transitions of a state machine. So if you're showing, you can be hidden or shown. I don't know the difference between showing and shown, but that's fine. And then we have some event stuff. Oh, sorry, overview is going to extend, it's going to emit events. Okay. So ripples shamelessly copied from the layout hot corner ripples implementation. So ripples, I'm going to guess, is probably like actual ripples. So animate ripples. We have a ripple. I don't really know what type that is. Is that defined up here? Ripples is a class that has an X and a Y, but also a PX and a PY. I don't know what the P is. I thought for a moment like DX and DY, like the infinitesimals, but I don't think so. Maybe point X and point Y. At any rate, we have a box layout, and its opacity is 0, which I think means totally transparent. You can't focus on it. It's not reactive and it's not visible. And then ripple 1 has some pivot point, so I guess P might be pivot. Ripple 2 has also this invisible box and pivot points at the same place. And same with ripple 3. And then when you add in ripple, you give it ripple, delay, duration, start scale, start opacity, and final scale. We draw a ripple by using a source image and animating it, scaling outwards and fading away. We want the ripples to move linearly or it looks unrealistic. But if the opacity of the ripples goes linearly to 0, it fades away too quickly. So we use a separate tween to give a nonlinear curve to the fadeaway and make it more visible in the middle section. So ripple.x and ripple.y are set to this underscore x and this underscore y. Visibility is set to true. Opacity is set to 255 times the square root of the start opacity, which must be defined up there somewhere. And then the scale x is set to scale y, and that's equal to start scale. And you had some translation. We're going to translate in the direction of negative px times the width of the ripple, and negative py times the height of the ripple, and 0, I'm not sure what 0 is, maybe that's the third dimension, right? So maybe this is just saying it's a two-dimensional ripple. And then we have this ease thing, which is presumably going to do the nonlinear scaling. Okay, what on earth? Let's see if we can find a GIF. No. Let's try Google. Let's try really emphasizing that I mean ripple. Set your windows on fire. Well, we can set things on fire. Let's see if there's anything on YouTube. I want ripple. I would just like this. It would be nice to see the animation so that we can kind of map what we're seeing in the code, but it's not finding it. Okay, this is a thing that's not for here. And I think that's about it. I'm going to see if I can find fire, but I bet fire is an extension. It's not fire row. Firefighter. So these are like emojis. We have emoji.json. Okay. Fine. I'll ask Gemini to draw a gnome related image. So draw a gnome holding a shell, a conch shell, where in an underground server farm, radiant light is emanating from the shell, creating a beautiful effect. It doesn't like drawing people. I think it thinks a gnome is a person. What if I tell it to like pixelate it? Not bad. I wonder what happens if I tell it to what's another kind of distortionary style, like the Picasso, Dali. How about draw a cubist? Let's try one more. How about a Dali? There we go. Not bad. All right. So that's Gnome Shell. I'm going to take a break for about 1 or 2 minutes, and then I'll be back and we'll take a look at the XLA compiler